All right, so in this video, I'm going to talk very briefly about the calculus of inverse trigonometric functions. Hopefully by the end of this video, you'll be able to determine the derivative and the corresponding integrals of inverse trigonometric functions. So before you watch this video, make sure you have already seen the derivative of inverse functions, the calculus of inverse functions video, so that you know this formula for derivative of inverses. I've already written it down. The other video to make sure you watch already is the inverse trig functions video. Make sure you know, or you at least you recognize that sine inverse of x can be written as sine with a little -1 of x. But please do not get this confused with sine of x to the -1 power, which would be 1 over sine x, which is the same as cosecant x. Please do not get these two things confused. That is actually the exact reason why we have another form of writing this, which is arc sine of x. I actually do prefer this method for calculus specifically because of that confusion. However, the downside is the calculators have a button for sine with a -1, cosine with a -1, and tangent with a -1, which is why we have to just acknowledge the fact that they are there. So as I go through and do this, please pay very close attention to the way we write this and how we figure this out. So I'm going to start off with trying to find the derivative d dx of arc sine of x. And so what I'm going to do is I'm going to think about what the original function was. Well, in this case, if I'm trying to find the derivative of arc sine, the inverse of sine, I'm going to treat sine of x as the original function, which means its inverse is, again, the one we're looking for, arc sine of x. So I got to find the derivative of f of x, which is cosine of x. And so what we're going to do is follow this formula right over here. And I'm going to take the inverse and I'm going to plug it into, the inverse, and I'm going to plug it into the derivative of the original function. So that means we're going to take cosine of x and I'm going to plug arc sine of x into it. And that's all under 1. It's all in the denominator. Now, by this logic, I'm going to think about it using this green triangle over here. So if I want arc sine of x to equal something, that means sine of, we'll just say theta equals x. So theta is my angle, so arc sine of x has to equal theta. Well, if I write arc sine of x equals theta, sine of theta equals x, I'm going to write that as x over 1 because normally we write this as fractions of opposite over hypotenuse. So that means x is my opposite side and 1 is my hypotenuse. That means I should probably go ahead and find that adjacent side while I'm sitting here thinking about it. So x squared plus, we'll call it b squared, equals 1 squared. 1 squared is 1. We'll subtract the x squared, so we'll have 1 minus x squared. And then we'll square root it, so square root of 1 minus x squared is this remaining side. Now that I've got that covered, I'm thinking about it this way. We said arc sine of x is going to equal theta, the angle. So I'll write 1 over cosine of theta. So I just need to look up here at my triangle and say, okay, if this is my angle here at theta, what's cosine? Well, that's adjacent over hypotenuse. So it's the square root of 1 minus x squared over 1, which is just 1 minus x squared under square root. Now again, this is in the denominator, so I'm going to put it all together, and it's 1 over the square root of 1 minus x squared. Now, important thing to think about is what happens if I change it, and instead of doing the derivative of arc sine, what happens if I do arc cosine of x? Well, that means the original function is instead cosine of x, and its derivative is negative sine of x. Now, important thing to realize is that if I, in fact, follow this train of logic with cosine of x and arc cosine of x, I missed a c in there, arc cosine of x, and its derivative is negative sine of x, the only thing that's really going to change is the sign of what I finally get as the answer. It's actually going to be a -1 instead of a +1 over the square root of 1 minus x squared. So again, I'm going back to that fact that I told you guys when we first started talking about the trigonometric functions in general, is if I start with a and I take its derivative, the sign will change from either positive to negative or negative to positive. Now, I'm going to erase some of this stuff because I don't need it. And the next one I'm going to do is I'm going to do arc tangent. So when I go looking for arctangent, I'm going to kind of follow the same process. I'm going to start off by saying, hey, what's my original function? Which, if I'm looking for arctangent, it's going to be tangent. So let me write this down. d dx of arctan x. And I'm going to keep this triangle in view because I'm going to need that again. So the original function is tangent of x. Its inverse is arctan of x. And the derivative of tangent of x is secant squared. Now that's going to add a slight wrinkle to this problem, but not too big, nothing that we can't handle. So important thing to notice here is that this is secant squared, not secant uh, x squared. So this is going to actually just be the secant function of x squared. So if I can find secant and then square it, will be good. So thing to think about again is if I want to find arctan of x, and I want that to be that angle there, theta, that means tangent of theta needs to be x or x over 1, which is opposite over adjacent. So I'll write x is my opposite side, 1 is my adjacent side. And again, we're going to have to find this hypotenuse. So use Pythagorean theorem, and it's going to turn out pretty similar, but not exactly the same. We'll have the square root of x squared plus 1 this time. All right, so there's my hypotenuse. Now, putting this all together into that formula over there for derivative of inverses, we're going to do 1 over, I'm going to use some big parentheses for the square part. We're going to do secant of arctan x. Okay, so arctan of x in there is going to give me that theta. Okay, so we're going to do secant of theta, and then we're going to square that answer. Now, important thing to remember is that secant of theta is really just 1 over cosine. It's the reciprocal of cosine. Well, cosine was adjacent over hypotenuse, so that means secant is going to be hypotenuse over adjacent. So if I look up here, the hypotenuse is the square root of x squared plus 1, and the adjacent is 1. So secant of theta is the square root of x squared plus 1 over 1. But don't forget, we still have to square it. And what's going to happen with that square root and that square root? Well, they're just going to go away. So I'm going to have x squared plus 1, again, in the denominator. So my final answer is looking at 1 over x squared plus 1, or I also see it written as 1 over 1 plus x squared. Again, the only thing that'll change, the only thing that would happen if I did arc cotangent instead of arc tangent is we change the sign. So it's negative 1 over x squared plus 1 over, or excuse me, negative 1 over 1 plus x squared. Now, like I said, one more time, I'm going to leave this triangle in view because I need it. And I'm just going to go ahead and start working on the last problem, which is arc secant of x. Okay. And so as I do this problem, you'll see a couple of things that are important to notice when I talk about this. So let's see. I'm going to start off d dx of arc secant of x. And the original function, therefore, is secant of x. Its inverse is arc secant of x. Again, this one's going to have a slight wrinkle, which is the derivative. The derivative of secant is actually secant x tangent x. So when I go to work on this problem, what I'm going to end up having to do is 1 over secant of arc secant x times tangent of arc secant of x. Now, thing to think about here, and this is going to be kind of important, is if I'm referring back up here to this triangle, all of these sides have to be positive. But I can actually plug in some negative numbers into secant. For example, I want you to think about it this way. When we talked about secant and arcsecant, in the last video, we said arcsecant's domain was negative infinity to negative 1 and from 1 to infinity. Well, but I can't have a negative side on this triangle. It doesn't really quite make geometric sense. So the way I'm going to incorporate that part into this statement is I'm going to, instead of just doing a regular x, I'm going to do the absolute value of x. Now, the thing is, if x is positive, it's not going to matter if I have the absolute values or not. It's only going to matter if I have a negative x. So just remember that there for negatives. The other thing to think about here, though, is I need to think again about how this triangle is going to affect with arcsecant x and tangent x. So let me think about this. Arcsecant of x should equal theta, the angle, which should imply that secant of theta is x over 1. Again, when we talked about secant just a few minutes ago, we said that that was hypotenuse over adjacent. So I'm going to label these things. X is the hypotenuse, 1 is the adjacent. I'm going to go ahead and find that missing side. We'll do 1 squared plus b squared equals x squared. So this is going to turn out just slightly bit differently. B squared equals x squared minus 1. Earlier we had 1 minus x squared. Now we've got x squared minus 1. We'll take the square root of it. So we have b equals the square root of x squared minus 1. I'll write that as the other side. And so when I come down here and look at my work, we're going to do, this is tangent of theta. And again, tangent is opposite, which is this side, over adjacent, which is 1. So I'm actually going to do times the square root of x squared minus 1 in the denominator. So my final answer is 1 over the absolute value of x times the square root of x squared minus 1. Again, the absolute values are important, especially for negatives, but you don't always have to have them if you're doing positives. Again, one more time, if I do arc cosecant, again, if I stick a co on that, the only thing that's really going to change is I'm going to have a negative instead of a positive. Okay, so that's kind of important there. These are all my functions, derivatives. I'm going to kind of scroll. Oops, I'm going to scroll down. Let's see, and there's all my recaps. The only thing I want to mention before I go is that if I said to integrate, let's say 1 plus 1 over x squared, you would say the answer is arctan x. If I asked you to integrate 1 over the square root of 1 minus x squared, you would say it's arcsine x. If I asked you to integrate 1 over the square root of x squared minus 1 times x, or with those absolute values, you would say it's arcsecant x. I don't typically worry about the negatives when I do integrals because you could just take the negative out using the constant multiple rule, but that's neither here nor there, so we typically stick with just arcsine, arctangent, and arcsecant. Hopefully this helps kind of explain all of the inverse trig functions in calculus, and I look forward to seeing you guys